Hey everyone, welcome to the channel Green Learner. Today we are going to understand a very important topic which is related to the passwords. When we create accounts with any banks or any other institute, we enter basic information like username and password. How this password is stored into the system, whether it is stored in the clear text password, the way that we entered, or in some other format. We are going to find out in this video. So let's get started with the basic requirements of the password storage that is going to happen. So first thing is that as a user, when I'm registering with the system, only I must know the password. No one must know that. Otherwise, they are going to use that. So at this point of time, just imagine that the password that we are entering, it is stored as a clear text in the system. So the second requirement is that no internal system should expose the password. So first requirement is that no one must know. Second is it must not be stored in the plain text. But for a second, we are storing that password in the plain text. So what can happen? So if that database got hacked, so the hacker has direct access to our accounts without any effort. They can just get hold of that database and they can access the millions of accounts very easily. Other thing is that if any of the employee of the company is leaving that company and they already had that access of that database and all those stuffs, they know that password and they can get the access of the actual user's account without any effort. So these are the inherent risks of exposing the clear text password in the system. That is what this second requirement is, that no internal system must expose the password in the clean text. So by now we understand that clear text password that we entered in the form in the user interface, it is not stored that way. It is converted into some secret form. We're gonna understand that what those mechanisms are in place, what are the best practices that are there, but it is not stored. For example, the password is password 123 we are entering. It is not stored as a password 123. It is converted into some secret form. That secret form is stored in that one. And the same mechanism is applied when we are validating, when again we are coming to the system, logging into the system. That same encrypted mechanism and hashed mechanism is in place to validate that passwords without knowing the actual clear text. Okay, so the second is difficult to guess. Usually when we have many accounts to maintain, online shoppings, educational institute, banks, so we tend to set the easy passwords. So it is the responsibility of the system to avoid that one. For example, very easy phrases like you start your password with your username, you put your password, your date of birth, start the password with your name. So application owners, software codes, we can put some logic to discourage these kind of password and ask the user to give a proper length password and with proper complexity, so that it is very difficult to guess. The second is hard to crack. When we have a proper complexity and proper length and then it is converted into a secret form, it becomes very hard to crack. Whenever the database got hacked or anyone got that secret form, it is very difficult. It is very difficult to get back the actual clear text password. And at the same time, when the hacker don't have the clear text password, they cannot get access to the account. When they have that, it is of no use of them. Nowadays you must have heard, like, there are many security events, many security incidents that has happened in the past, that food chains websites are there, drives, many applications are there whose credentials are exposed in the credential got hacked and they got a hold on the account, but they cannot use that one because that is not stored in the clear text. It is stored in some secret form and they cannot use that directly to get access of the account. So this is the thing that our system must take care of this one. At the same time, it is hard to reverse engineer, means that if anyone has got that secret password in real time, we cannot say that that secret password cannot be reversed back to the clear text one, but it should be very difficult to do in real time. So by keeping these requirements in mind, let's see what are the different available options that we can use. So now the job in hand is that how to convert this clear text password into some secret form and store that password into the system. And When user again is coming to the system, logging into the system, then we have to validate. It is the responsibility of the software as well to validate that one. So how is gonna that happen? So let's see what are the available options. So first one is the encryption. We all know this word. What is this encryption? So encryption is some kind of logic, some kind of pattern is there. So if we have some clear text password here, let's say clear text password is there, and we are passing it through this encryption mechanism. Let's see, this encryption function is there, we are passing it through it, and the what we got it is a secret, some secret form we are getting here. So this encryption mechanism, encryption function gives us this secret, and this secret we can store in our system. So how this encryption happens, there are two mechanisms of this encryption. So I'm not gonna deep, but I can give you the brief of that one, that we have two mechanisms: symmetric encryption and asymmetric encryption. So in both the cases, there is some form of private key in place that is used to encrypt that one. So for example, if I give the password like password 123, so we have this private key which is known to the system only. It is not shared with anyone. It is very secured key that is stored in the application itself, and this private key is used to jumble this clear text. This is passed to this encryption mechanism uses this password here, and then it generates this secret. Okay, and that secret is stored into the system. And when again user is coming to logging into the system, they give this clear text password. So what happens when we are using encryption, so that whatever secret that we have stored in the system, using this private key, we have to convert back into the clear text password, then we can validate it while logging into the system. So this is the one way that we can convert the clear text into secret and validate when user is coming back to the system. This is the one way, but there are some risks with this one encryption. So that is why we have another system. So you see the encryption, what is the main problem with this encryption? That whenever we have this input and we passed it and we got the output, and the output in this case it's some form of secret, and that when validation is happening, that output we are converting back into the clear text. Okay, so this output we can convert, so it is the bi-directional, right? So this whatever encrypted string is here, we can convert that back to the input if we got the private key. So this private key, when the hacking happens and someone got the hold of the database and somehow they got the private key also, they have now the access to all the username and passwords that are stored in the system, whether they are in the secret or not. Now the responsibility is only on this private key that we have to secure it. So this is the inherent risk. So it is better than clear text, but still it has one risk of that one, that it is a bi-directional. So is there a way that it's something unidirectional, that we can convert the input into secret, the password into secret, and some inherent validation, some internal validation can happen, so that it is very difficult to get the clear text password. So the next mechanism that we have, hashing. So hashing is a mechanism where we again give some input, and input we are saying that it is a password, and when it goes through this one, it gives us some secret, and that secret we cannot get back with input. So in real time we cannot get that. So actually when it is going through a hashing function actually, in a layman term we can understand, it is a layer of operations that happens when we have just input the like say password, we are giving password. So it has different layers of operation like L1, L2, L3, L4. After that, that secret gets generated. So if we have to revert back to the input, so we have to come back to this layer and this layer, and the details of these layers, once it is converted into the secret, these layers of information that we have, they are not stored anywhere. So it is just on the fly, internal to this hashing function only, that how this secret got generated. So let me take an example of this one. It will make it more easy. So let's say a mathematical number that we have 10, and I say that you give me some inputs that can give the result of 10 by using any mathematical operations. Like we have plus, minus, we have multiplication, we have division. So choose any number, any mathematical operation, and you have to get me the number 10. So say how many numbers such we have. So we have 2 plus 8, we have 1 plus 9, we have 2 into 5, we have 20 divided by 10, and all of these are resulting us a number 10. So which of these are the actual one, which is the of 10? So this is also a property of hashing function, that more than one inputs can result in the same output. That is what I'm trying to explain here. So when more than one input can result in a same this is the conflict scenario, but it can happen. More than one input can come to a same output. So it is very difficult to guess that which input it is that, right? So it is unidirectional in this way, and it is very difficult to get back to the input. And if we nowadays we have supercomputers, very fast computers nowadays, these days in industry, and the processing power is increasing day by day. So this hashing function also must be improved by the time to take care of this situation also. Otherwise, when let's say you are using a mechanism which was a very good 10 years back, and after 10 years, as of now, you are using the same like legacy mechanism, the existing hardwares that are there, processors that are there, they can very easily crack that system. Okay, so this is something that we have to keep updating, and this is very important for us. Okay, so now I hope we got the understanding of the differences between the encryption and hashing, and what are the advantages and disadvantages of keeping those. So it's clear that we cannot use encryption, we have to use hashing, and on top of that we can use encryption to further secure this one. Okay, so let's go ahead and see more about this one. So there are different secure hashing algorithm that hashing function we talked about. There are many such algorithms that we can use. By the time we have improvement, we have legacy systems also. So we are going to talk about that one. So before going to that secure hashing algorithm, let's see some few terms related to that one. So first one is salting. So what is this salting? So we already got the understanding of this hash. So let's see, this is a hash function, and this is some form of input. We are passing this one, and it is giving us a secret. Okay, so if anyone got hold of these hashes, so they only have to look at the pattern, and they will keep in place, they will put in place a super fast computers to get back the input. So it is slightly, we can say, only one layer of thing, and they can get that one input. So what is the thing this salting told us? What salting concept gives us, that instead of directly putting this input into hash, you put some string with this one. Okay, so you generate some number, some form of random string with each input that is coming here, and along with this input and this string, pass it to the hashing. So now we have input plus salt. This salt is that unique randomly generated string that we are passing through hash, which is giving us a secret. So see, now we have added, even if user is giving us some easily guessed password and easy string here, the salt is the strong one that we can put, and both of these, when we pass it through the hash, it can give us a more complex secret, which is again very difficult to come back to the previous one that we have. And the more unique property of this salt is that it is unique for each password. Right, so that is also stored along with the hash password that we have. So the internal algorithm works in the way that when you give it, uses that salt to generate the secret, and when you come back to logging into the system, it uses that information that is stored in the database to validate this one. So this is what salting talks about. Salting tells us, and it adds one layer of security again. The next concept is about peppering. So peppering is different. We can say that it is kind of salting, but a bit different. So the word salting was that for each password, it was a unique random string generated that was stored along with the hashed password itself. But peppering is something, there is some private keys there. I hope you will be able to relate this one. Some private key is there that is not stored along with the hashed password. So we have input, we have hash here, hash function, and we have secret. Now what this peppering concept says, that you use a private key to further encrypt this secret. So encrypt it, get the secret too, and store this in the database. So use this private key, to further encrypt this one. And this private key is never stored along with this table, along with this secret that we have in the database. It can be stored in a hardware secure vault or any other database or any other file system, but not with the database. So now when the database got hacked, this system got hacked, hacker got this secrets only, and they do not have the hold of that password, so they cannot get the actual hash secret here, and they cannot get the hash secret, so they cannot get back this. So this, you see, when we add these layers, it is securing the system further, and it is making the life of hackers very difficult to get the original one and to get the hold of the account of the actual users. So this salting and peppering adds that layer here. So let's see the next concept in this hashing mechanism. So next one is the work factor. Remember, I was talking about the making the hash calculation very difficult, because by the time the hardwares are getting improved and the performance is being increased, and we cannot live by using the mechanism that is very old. Okay, so we have to keep upgrading that one. So work factor is in addition to that one. So work factor is a kind of iteration, kind of making the hash calculation very, very, very difficult, and it makes that CPU intensive. So by giving the work factor, we can say that when a specific hash function, how much time it is taking. So for example, when we are not putting a specific work factor, suppose a hash calculation take 10 milliseconds to calculate the hash one. Okay, and 10 millisecond is a very, very few, very less time, and we can put in place a very fast computer, supercomputers in place, and it can do the error and trial method to validate the passwords, right? And when we put this work factor, we can make this hash calculation very easy, very, very difficult actually. So when we put like a work factor of 10, so maybe that can multiply that 10 milliseconds by 10. So it can make that hash calculation 100 millisecond. Okay, and we can keep increasing this work factor. It can make that hash calculation very difficult. So it is here it is very here we have to keep in mind that we have to maintain a balance between securing the password and between making the life of hacker easy, because we also have to validate the actual users, and that should not take like unusually long time. So we should keep this like a logical value, so that it is not impacting the user behavior, as well as making the hash calculation and validation very difficult. So this is what work factor tell us. So now let's see some of the cryptographic secure hashing algorithms that we can use for our purposes here. So at this time when I'm making this video, Argon 2 category algorithm are the best to use for hashing the sensitive data that we have. Argon 2 has different flavors. Argon 2D that you can see in the screen here is most suitable for the cryptocurrencies. When we have password, Argon 2i is the best possible. And if we are not sure about this one, Argon 2ID is something hybrid that we can use here. Apart from Argon 2, if we are like in somehow we are not able to use that one, next suggested way to use that one, that we can use Bcrypt. If it is not available, then we can use Scrypt. These are the best cryptographic secure hashing algorithm that are in place that we can use for the different use cases. If it is also not available, these are the PBKDF 2 that we can use. If it is not there, we can use SHA. We have SHA 256, SHA 1, 2, 3. These are the different categories for this one. MD5 is yet another that we can use. So that you are seeing, these are like in MD5, it's something that was like legacy, and they are not secure to use at this point of time. They were like a pretty long time, and the hardware has become very much efficient for these algorithms to use. But I have put it here just for knowledge that these were in place sometimes to secure this password, to generate the hash one. They are still in use, but not for the password, but other informations that we have as per the use cases, that files that we download. You see the MD5 checksums and all those things are in place that we can still use. So they are not obsolete, but for password, these are the like most secure way that we can use. So use this Argon 2, then bcrypt, then scrypt, and then accordingly. Okay. So these are the some of these ones. So the detailed knowledge, if you want that one, there are Wikipedia pages and other related links on the Google that you can find it, and you can go and read about this one more. Now coming to see the code example, I'm going to show you the code example of Argon 2 using the basic algorithm, using the basic code. So how we can use Argon 2? So there are libraries. We do not have to do implement all the algorithms that is in place. There is libraries that we can directly use. So this is the one, latest version is 2.11 that we can use here. So I already have added this one in our project. So let me show you that. So we have this sample application, and in here we have actually one of the services that I'm building here, and here I have added this library here, and it has downloaded that into my system, and I can use this one. So we have this Argon 2 hashing demo file, which I'm going to put some of the code lines here. So Argon 2 factory, so create. So if you see the create functions that is there, let me use this one, and let me import class. Let me show you this method. So if you see the create here, it is taking some of the things by default, like default salt length, default hash length that I was talking about, this salt length and hash length. Yeah, I forgot to tell this one that we were talking about salting and peppering. Salting is something that Argon 2 adds it by default in its algorithm. That is why it is taking this salt length. So if you want to see these values, by default this length is 16 and this hash length is 32 here. So if we want, we can change these things, but for the demo purpose, let's keep the by default one. And Argon 2 type, by default it is going to take the Argon 2i, that we talk about the three different versions, 2i, 2d and 2id. So we are going to go with the default one here. So let's go with the Argon 2 only. Okay, so now we have this Argon 2 instance. Now we need some password, like user password, like string password. So let's see, this example is like some super secret is here that user is giving here. Okay, and Argon 2 now had some handy method to get the hash of this one, and you see the first method that it has. So it is taking number of iterations, memory, parallelism and data. These are the four values that it is taking here. So first is the number of iterations, how work factor that we were talking about, right? So how many we can give it. So let's say give it the value 10, and the next one is the memory, that how much we can give. So let's give it like around 64 MB we are giving here. The next is the parallelism, like how many parallel threads that we want here to be considered here. So let's see, we are going with the value 1 here, and the next is the actual password that we are going to pass here. So you see, it is not taking the directly the string as a password, but it is taking the char array. So we have a handy method to convert that one to char array, so that we can use here. Okay, so this when we use this one, it is going to give me the hash of this password here. So let me print this hash here. Let's see what value it is giving us. At the same time, we want to see how much time it is going to take. So it is going to take the time proportion to the values that we are giving here, number of iteration, memory and this parallelism. So first let's see the time, normal time that it is giving here. To calculate the time difference, we can use this datetime API start instant dot now that we are taking here, and after generating this hash we want to print the time. So how much time it took. Unit, we have handy method for this one, dot milliseconds dot between, and start time I have to give here, and the end is that instant dot now. So this to get the time difference that we have. So this is ready. So by doing this simple line of code that we can use to generate the hash, let's see how much time it takes to give us the hash, and how does that hash look like. It is gonna take time. Okay, good. So that is why it said that number of iteration, that is, it says work factor, we have to choose that wisely, because we have to keep the balance between the actual and this one. Yeah, you see it took this is the hash password that we are seeing. So it gives the result in some specific format, that Argon T version that it is giving, that what type we used here. Memory, it is giving us 65536 that it is taking here. 10 is the number of iterations that we have given here, it is taking, and parallelism P is the one that it is giving, and version it's 19, it's some value that it is giving, not sure what is this one, but it is the some fixed value here, and this is the actual hash that it has generated. Okay, so you see time it took almost 2.3 seconds here, 2302 milliseconds. Okay, and let's run it again and see how much time it takes again. Okay, so keeping the value same. Yeah, again it took almost 1971 milliseconds, but it took significant time, right? So run it again. It is not gonna reduce it is not gonna give very much difference. It will be around that only. Yeah, see it again, 2028. So if I change this value to somehow 15, so let's see how much time it takes. It will be incremented like 25 or something like that, or more than that. Let's see, because we are increasing this iteration here. See, it is almost 3000 milliseconds. So you see the importance of all these values, and these are all the configurable when we are using in the real-time application. We are not hard coding this one, but we are making it configurable so that anytime we can change it. And if you want more detail about this Argon 2 hash, you can go to this one here. You can see the actual algorithm that is in place here. Hash is here, iteration, memory, and if you come here, you can see this password, byte array, hash bytes, all those things you can see. This is in the library itself, and code walkthrough that we can see. And there are some best practices that we have to do, like when we have this hash generated, and how when it is generated, we also have to wipe the clear text, because we are using, and this is already in this instance here. So how we can do that? So that is also very easy to do that. Wipe array is the method that we have, and that password dot to char array we have to give it, and it is gonna clear that one, that password from the instance. So yeah, so probably put this here. So you got the idea how to do this one, right? So wipe array is the method for that one. And now the important thing is that how to validate this. When we have this hash stored into the system, user is coming and giving the input, how to validate that one. So we have handy method for that, verify. So verify, first input that it is taking, it is gonna take the input password. So when user is giving this input password, so I'm just giving it the number and convert it to char array. That is what it is expecting. And the second argument is the hash that you already generated when registering this user account into the system, and this is something what is in the database. So this is the hash value here. So it is going to give us the proper result for us. So it is giving us some result. Okay, so I think it is taking a string char. Okay, so I reversed that thing. So actually this first argument is the hash one that is in the database, and second argument is the input password that we have entered. And this verify method is going to give us the result accordingly by applying the internal mechanisms of verifying the password. If you want to see, you can go and look at this one. So this is also inherently it is also gonna take, because this input that you are giving internally, it is going to convert that into this hash itself and going to compare that. So it is going to take time as well, the same way that it took initially. Okay, so this is how we can convert the hash. We can verify this one, and this is how it concludes this demo here, right? So the basic demo that I wanted to give here. So what is next? The next important thing is that this is something we have to understand, how attackers crack password hashes when we have it in the store. So for example, we have a user stored in the database, and hacker got hold of that one. So how they can crack that password? So first step is that they are going to guess the user password. They are going to convert that into some they are going to apply some hashing mechanism and get the hash string, and then that hash string they are going to compare with the what they have got from the database. And if that validates, so they can know that what is the clear text password of that one. So this is the 3 step that they do. The next one is that before concluding this video, let's see the best practices around this one. So first one is that we have to super secure our databases so that it is very difficult to hack at the first place. And when they have got hold of that database, let's see that has happened. So hash all the password as and use strongest hash function possible, so that even if they have got the hold of that password, they cannot use that one. Next is that when we are using the modern hashing algorithm, so salt is inbuilt into that one, that is already added into that one. But if you are using legacy algorithm, make sure that you are using salt, and additionally try to use the peppering also, that adds additional layer of security. Pepper the password itself that we just talked about, and check the password against dictionary list that we talked about initially in the requirement, that common password like DOB, username starting, some emails, and month, year. This must be avoided. And length is also important, and it is also keeping in mind that password length that we keep. Sometimes we say that you have to put small caps, numbers, characters, all the things, and the length is also important. If we have the discussion about this length and complexity, length is more important than the complexity. I'm going to give link in the description box. You can go and get the more detail about this one. And put validation at last. So when we have front-end systems to validate the password, so put restriction at every level, that some common that policy, password policy we have, like minimum length, all these characters that are there, they have to be validated at all the levels. And when we have like certain attempts, like 3-4 attempts in a day, lock that user, don't allow to validate that password. So these are some things that adds the layers of security, and then that is very important here. So that's all about this video. That is the best practices, and you can get whole lot. So that is the like whatever I have told you, you have got the glimpse how this works. And if you want the more details are in the description box itself. You can go ahead and check out that one. These are the some references that I'm directly giving and putting the in the description box also, that you can go ahead and check out. So this is the like kind of theory lecture about this one. And if you want to see this implemented in real-time microservices architecture and application, I'm doing that right now on the same channel here, that you can check out. Let me show you that. So this is the playlist that I'm working on hard this one to complete this one. So password and all those things, I'm going to use this Argon 2 mechanism, and we have used this library here, Argon, this one, right? Other when you are using Spring Security, that encoder Argon 2 comes with that one. So we are going to use that one with the system itself. So I'm going to apply that in this video. So make sure that if you're interested in the practical examples, do check out this series. So that's all about this video. Thank you very much for your time. And if you like the content, please don't forget to like, share and subscribe the channel and share it with your friends. Thank you very much. I'll see you in the next one. Bye bye.